8 times 7 times 6. What do you have? 56 times 6 will give us what? 300 and it gives us 336 plus 20, right? And that will give us what? 356. I hope that is clear. So let's look at more practical example on permutation. So now, let's look at arrangement of distinct objects. We are still under permutation, you know. So we have 3 examples here. Example 1, we have that in how many ways can the letters of last thing be arranged? Now, if you look at the subtopic, you will see that they say arrangement or distinct objects. So objects in the context of these first examples are representing letters. And then you will see that in the letters that we are considering for last thing, there are no repetition of letters there. We have single L, we have single A, single S, single T, ing. So when you have distinct objects, this is how you are going to do it. In how many ways can the letters of last name be arranged? They are asking us that how do we, in how many ways, how many times, or how many ways can we arrange last name? So what do you do? How many letters do you have in this place? You have 7 letters. 1, 2, 3, 4, 5, 6, 7. So you are arranging 7 letters. 7 different letters. You are supposed to pick 2 ways. Is it that you say that? For the arrangement of last name, solution. For the arrangement of last name, you say for the arrangement of last name, for the arrangement of last name, we have 7 permutation 7. We have 7 letters, right? And we are trying to arrange how many letters? 7 letters. So that is 7 permutation 7. We are trying to arrange all the letters. It's not as if they ask us to arrange particular numbers of letters in that last thing. It's only the last thing that we are considering, no other conditions. So that means we are doing 7 permutation 7. And if you want to do 7 permutation 7, what do? You use the initial formula that we have discussed, which is what? N permutation R, Abi? N permutation R is N factorial over N minus R factorial. So in this case, your N is 7 and your R is also 7, Abi? So you have 7 factorial over 7 minus 7 factorial. Because you are arranging 7 letters out of what? 7 letters. No limitation, no deduction, no reduction. Do you understand? So, and it is what? 7 factorial. We all know that 0 factorial is what? 1. So, 7 factorial over 0 factorial. That gives us 7 factorial. And this is why you say that each time you are asked to arrange a particular object, and you are not removing anything, there is no restriction, there is no repetition, what do? You just pick the same number of elements that you have in that object. The same, it can be letters, it can be anything. The same number of objects that you have, you just pick it and put your factorial. So for this case, I will just say, how many times do you have in last thing? 1, 2, 3, 4, 5, 6, 7. Just put your 7 factorial. 7 factorial. If you evaluate 7 factorial, what are you going to have? That's 7 times 6 times 5 times 4 times 3 times 2 times 1. And that will give us, what would that give us? 840? 840 ways, Abby? 1,040 ways. Is that it? We are going to have 5,040 ways. So let's look at example 2. I hope that is clear. So let me take that again. Let me take a recap of that. When you are asked to arrange a particular object, and there is no selection, there is no, how will I put it? There is no condition attached to it. Just arrange these letters. How many letters do you have? 7 letters. How many letters are you arranging? 7 letters. So it is just 7 permutation 7, and that's all. But if there are restrictions, the restrictions could be how many ways can you arrange last thing if ing must be together? How many ways can you arrange last thing, if AST can be together. Those are conditions that you have to implement. But in this case, we don't have any conditions. So just arrange last term. In how many ways can you arrange last term? You count number of letters or number of objects that you have, and then you add your what? Factorial, and you simplify. So for this one now, in example 2, we have, in how many ways can the word boy girl be arranged such that BGI must be together? You can see that in this question now there is a condition. It is different from just in how many ways can boy girl can be arranged. Abi, in that one, if it has been in how many ways can the letters in boy girl be arranged, or the word in boy girl be arranged, what do? You just count the number of letters that you have in boy girl and put your what? Your factorial. But in this case, there is a condition. The condition is that whichever way you want to arrange it, BGI must be together. Whichever way you want to arrange it, BGI must be together. So now let's check it out. You have boy girl, but we are not arranging boy girl as it were. We are arranging BGI because they said this and this must be together, right? So after picking BGI, what do you have left? You have OYRL. So how do you simplify this? Number one, you first of all take the first 3 letters, BGI, that must be together. You first of all take them into consideration. When you take them into consideration, how many letters do you have there? 3. That will give us 3 factorial. Now that you are taking this into consideration, you keep these 3 factorial aside. And then you go back to this place. If you now want to count, you will not count BGI as a single letter again. Remember that you have combined them. So now if you want to count, you count them as you will not count them as different letters again because you have combined them and you are taking them into consideration. That is why you have these 3 factorial aside. So now if you now want to count because of the other ones that you left aside, what do? You count this one as a single letter, not as separate letters anymore. You count them as what? A single letter. So when you want to count, this will be 1, 2, 3, 4. So in the remaining arrangement, what is left to be arranged? 4 letters. I'm going to take that again. You want to arrange boy girl, but there is a condition that is attached to it. The condition is that BGI must be together. The condition is BGI must be together. So the first thing you are going to do is you rearrange the letters. And when we rearrange the letters, BGI of course are together, right? And then we left the remaining letters aside. Remember that the remaining letters, they are still part of the letters we are. You will see that we have rearranged this already. We have BGI and then we have OYRL. So now if you want to evaluate this, what do? You first of all take BGI into consideration, which we have done. So when you take BGI into consideration, how many letters do you have? 3 factorial. You do that and you keep it aside. Now, when you keep BGI aside, it means that in every arrangement that you want to do, you will be seeing BGI as what? As 1 letters because they must be together. You are not separating them again. Anyhow you want to arrange this, BGI must be what? Must be together. So if you want to put other letters into consideration, when you want to count, after these 3 factorial, what do? You say times. How many letters do you have? 1. BGI. The whole of BGI will be 1 letter. Then OY, how do you? This one will be